Welcome, everyone, to our next session with John Page, who you've all met at our keynote speech this morning. So the next session will be the recent additions to query and aggregations. And John, at least internally in MongoDB, doesn't need any introduction, has been with MongoDB for almost 10 years, is a distinguished engineer, and has been working on document databases for over 25 years, and is a firm believer that now the document model is the best of all worlds. So please welcome John Page.
Guten Tag, ich heiße John, ich wohne aus Schottland und ich habe Deutsch an die Schule gelernt. Aber mein Deutsch ist gar nicht gut und sein Ohren tut weh. Also ich mache das auf Englisch, ist das okay? Okay, for anyone that didn't get that, my German is terrible and so I'm going to do this in English. I don't know how bad that was, probably really bad. Hi everybody. I was asked to give a presentation here today, and I was asked to present something that was presented in New York at MongoDB World, entitled New Additions to MongoDB 6. Now the thing is, I said, well, one, you want me to make that a little bit longer than it is. Two, people frequently say to me, what's new in MongoDB? And the thing is, they're asking, what's new to me in MongoDB? They don't really want to know what MongoDB put in the latest release because they haven't actually looked at any new functionality for 7 years. So I'm doing what's new in MongoDB, but really I'm doing a kind of greatest hits version here. So I'm going to be telling you about features that are new in MongoDB in the last 7 years. Now, that probably means that some of you are going to be like, I've seen this, but I'm hoping I'm going to surprise several of you with things that you haven't seen before. I surprised myself putting the presentation together. So, first I'm going to start with a bit of a health warning. This presentation contains JavaScript. Oh, they said there was no way I'd get a German audience to laugh. Thank you very much. Okay, so I'm doing this. I'm doing it in the MongoDB shell, or photos of the shell. So the code is JavaScript, but this isn't your grandmother's JavaScript. JavaScript itself has changed a lot since MongoDB came along. So I'm going to be showing some examples in modern JavaScript, which interestingly makes it look much more like Java or much more like .NET, and certainly much more like your queries should look. If you're still writing queries that look like big lumps of JSON, and you're going, this is an ugly way to write queries, you're right. MongoDB queries shouldn't look like lumps of JSON, and that is an ugly way to write queries. That said, in MongoDB we query by creating objects and getting those objects from functions. And I'm going to walk through some of that. What I don't really want you to do, though, is focus lots on the code examples in this. I promise you that all of this presentation will be available for everybody who completes the form and the evaluation at the end. Okay? So fill in the evaluation, and you will be able to get hold of the slides and go and read the code examples. What I need you to do is kind of listen to what I'm explaining about what they're doing, get the concept behind it. Is that okay? Now, can I hear a yeah? Good. Sehr gut. Okay, so I'm going to start off with an example that everybody's seen before, a nice simple query, but I'm maybe writing it in a way you haven't seen before. So I'm going to do a find, and I'm going to do a find with some fixed values, okay? And this is just going to give you a little feel for how I write queries. This is how I use MongoDB. So the things I'm looking for, I declare as variables, and then I create an object from those variables. So if you look at that attendees.find, I know it's a little bit small, that's a little bit of a shame, but there's it's find curly brackets, first name role. Quick show of hands, this is ES6 JavaScript, right? Where I can create an object just from a couple of variables, and the object's variable names will be that. Who's seen that before? Who's not seen that before? A couple of people. Just out of interest, who thinks this is like easier to understand than the usual making an object? Yeah. 2, great, okay. You're not going to like the rest of the presentation. Anyway, so, the way MongoDB is queried, you query with objects. And in JavaScript, you can just create that object from a couple of variables. In Java, you'd actually wrap it in an and brackets, and then the list of variable names. Anyway, you've all seen this kind of query before. Hopefully, I'm not showing anybody anything new here. Here's another one. And this time, I'm doing, first name is Hans, and role is in developer and analyst. What's that is in thing I'm doing there? Well, I don't like to see lots of dollars and braces and curly things in here. So I have a whole set of functions in JavaScript predefined that do all the basic things like and or and XOR. They're in my shell file. They're in a node thing I include. They already exist in languages like Java and .NET. So again, I can define that role is in these and first name is Hans, and then just do a find like that. Again, I find it much cleaner, much easier to read, especially as queries get larger. But we're still doing an exact match search, and everybody's seen exact match searches. So when am I going to get onto something new? Well, what about an expressive query? So here what I want to say is the role is developer or analyst. Their first name is Hans. But then I also want to say that their number of skills is greater than 2. So how do I check that the size of an array is greater than something? Well, I can apply an expression to that array. So I can apply the $size operator to that array, and that's going to turn it into a number, which I can then use with greater than to see if it's greater than or smaller than. And if I assign that to a variable called $expression, then my query can be find first name is this, role is this, and this expression. So then I'm able to find just that one record where we have Hans Schmidt, he is a developer, and his skills are Java, Node, and Ansible. So, the takeaway from this, it's not necessarily about reading and understanding how I do this, what the code is just now. It's the fact that you can query for not just what a value is, but what some function applied to that value is. You can query for the size of an array, or as you'll see, much more powerful functions applied to them. I also said that I tend to create functions around bits of code, around object creation, just to clean up my code, so that I don't have some huge slew of JavaScript or nested kind of fluent API. So I'll define a function like size that returns an object, $size is value. And then I can do that as let expression equal and greater than size skills too. So I actually get that nice kind of functional way of writing queries. So what about something more clever? What about we take these and we say each of these students has a name, subject, a year, and some test scores. And I want to find all the students who have an average score of greater than 90. So I can write a query like this. I can say, let subject equals mathematics, let year equals 2012, let average score equal to $average test scores. So I'm computing the average of that at query time. I'm running through and I'm computing the average from that array at query time. And then I have to put that in an expression. So I'm going to say the expression is greater than the average score, 90. And so that query, subject, year, and expression, is going to find me all students doing mathematics in 2021 where the average of that array of scores is greater than 90. Okay, everyone's gone very quiet. Quick show of hands who understands the concept. Good. Quick show of hands who still not very sure about the code. Oh. Ah, good, a waving hand. At least somebody admits they're going to have to fill in the survey at the end so they can have a look at the code and understand it better. Quick show of hands who this is new for. Couple of people. So at least some people this is new. This is where we start to get into things that might be new. So this came in a while back, and a lot of people have seen expressive queries. I can also do expressive projection. So when I retrieve my data from the database, I don't necessarily need to apply changes to it in my client end. I can have MongoDB actually transform that data for me as it returns it. Yes, we can do projections. We can say, include these fields, don't include those fields. Sure, you're all familiar with that. But if I want to retrieve those records and I actually want that average score back, then I can put that in the projection. So I can say the same query as before, find everybody with an average score greater than 90. And then I can say project the first name, the last name, and also a field called average score that contains the average score. So I can actually, it's computed that field, it's used it in the query, and it can return it to me. So now I can do find subject year expression and return projection. Return me that average score. So I can apply pretty much any function, any transformation to my data before I return it to my end user. Just checking I got that right. I did. So that's all well and good, but I'm sure somebody amongst you is thinking, I wonder how well that indexes. You know, how quickly can we find somebody with an average score of above 90? And yes, that's a problem, because we don't currently have function-based indexes. So it's not really going to be able, it's going to be able to index mathematics in 2001, but it's then going to have to compute the average for each of those to work it out. So what if we wanted to store that average in the record? Well, we can use expressive updates. And expressive updates allow us to send to the server an instruction that says, for each record matching this query, I want you to set the following fields based on maybe some data I send you, like a normal update, but also on the current value of the other fields in that record. So I'll give you an example. Let average score equal the average of test scores. db.students.update many. I'll just tell it to update every record and set the average score. So now it's going to go through that data, and it's actually going to compute the average score from that array and update it inside that array on the server. And every one of those records is going to be updated atomically. Now, if you tried to do this yourself, now you're in pain, because you're going to read some from the server, and you're going to calculate it, and you're going to write it back. But what if somebody added some more things in the meantime? You know, you would have to basically disable other access to the database, or you'd have to do a whole bunch of locking stuff. You really want to, not to mention you're pulling your whole database out and writing it back again. So being able to push something down to say, hey, compute this new field based on some other values in this is a really, really powerful feature. Okay, I'm going to do this again because I love interactive and you've all gone super quiet. Show of hands, who has seen expressive updates before? Right, we're down to about 5% of the audience. Fortunately, some of the employees did put their hands up, so that's good. Okay, so now we've got test scores, and we've got the average score, which is the average of those. Can anybody see what could go wrong here? Yeah? We get some new test scores and the average is no longer up to date. This is true. So what we need to do is, one, we need to make sure that when we add a new test score like this, we also tell it to update that average. So I'm able to say, okay, for this record, let new score equal 94, let test scores equals, and then we get into some interesting syntax where we're doing concat arrays, because basically, because we're doing expressive update here, we need to say, we can't use $push anymore. We're saying, right, I need you to take the existing array and bolt this value on the end of it, and also recalculate the average scores. So now I can do students, update many, update this student, and add their score, and also recalculate average scores. So we can do that. So technically, it's not a problem. So what's the next problem that we face? The next problem we face is the developer that forgets to do that. Okay? Because you can make sure you keep the average up to date with the scores, but can we make sure that people remember to do that? Well, of course we can. We can use expressive validation. So MongoDB has a really rich and powerful way of validating the content of records. We talk about MongoDB being schemaless, ruleless. Well, yes, it can be. And that's fine, but it never hurts to have some guardrails in there at some point. So yes, we can say, this field must be a double. This field must be between 5 and 10. This must be a string of at least 6 characters and no more than 15 characters. This field is mandatory. But we can also say, this field must be the average of that array. So we can apply an expressive validation rule to that data so that a developer cannot break it. If they go in there and they add or remove a value and fail to tell the server to correctly calculate the average value, it's going to refuse. So in this case, I've said average score is the average of test scores, right? Here's an expression. The average score field is equal to the average of the test scores. That's what that code says. As I say, fill in form, read it later. I'm going to run a command to update the validator on this document type to say, make that always the case. And then when I try and just push a test score in there, I get an error that says, no, sorry, that value is no longer equal to the average of that array. So we can actually enforce those constraints between values. Okay, show of hands if you've ever seen that one before. Oh, I'm going to have to work really hard to find something new. That was 4 people. Okay. Anyone think this might be useful? Anyone finding the talk useful so far? Oh, more laughs. Okay, good. That was like a nervous laugh, but that's good. Right, so I asked my colleagues, I said, I'm going to tell them about expressive stuff, because that's really good, and nobody seems to know it. What else do people not know about? He said filtering arrays. How many times do we see somebody, when they want to filter an array, they use aggregation, they do an unwind, a match, and a group. Unwind, match, and group is a massive anti-pattern. Because unwinding is nice and cheap. I can unwind into multiple documents. And a match to then filter those generally isn't going to cost me anything either. But when I have to group things back together by ID, the problem is that I take a document, I unwind it into multiple subdocuments, I tell it to group it together, but it can't just know that that set of subdocuments is a group and it just bundles them back together. It kind of has to hold that document in memory while it gets through everything else in the database, just in case anything else appears with that ID. So if you find anything in your code that's doing unwind something, normally match, group by ID, that is a phenomenal anti-pattern, probably 10,000 times slower than it could be. Or you can use $filter. $filter is something you can just apply to any array to say, hey, pick the following things from the array. You know, it's a really simple concept. The idea in every programming language of something that takes an array and some function that chooses elements of that array and returns a subset of the array exists. Well, it also exists inside MongoDB, so please use it. And that comes to the next one of these, and this is the even more classic anti-pattern based on the same thing. How do I sort arrays? How do I get a database to send me back an array sorted? Or more commonly, I'm actually going to sort the array and then just take the first 3 things from it. So in each document, find an array, sort the array. So people will do this. They will unwind the array. They will sort by the unwound thing. They will then combine them back together by grouping by ID, and they'll use this to find, a sorted version of the array. So here's the problem. We unwind it. I said that's not very expensive. It's basically just creating multiple documents in the pipeline. Then we sort it. Well, now, unfortunately, that's going to be an in-memory sort of your entire database or your entire set of results that you're working on. That's going to really hurt. There's no way you can use an index from something that's been unwound out of an array. And then you're going to do a group, which means it basically has to hold all of those things in memory because it doesn't know that they're specifically ordered. So this one, again, changing this to this, which is just sort array, can literally cut your CPU and memory usage 10,000 times for that query. I have seen people apply this and come down from 5 minutes to milliseconds. So, be aware. You should never be unwinding and then regrouping by ID. And I bet if you go through your code bases, you're going to find that one. If you've used aggregation, somebody will have done that. So this is added in 6.0, sort array. We've had various ugly hacks for doing it many years. We've had elegant hacks and ugly correct solutions, he said, looking at you carefully. This is just elegant. Just sort array. It's just going to turn it into a sorted version of the array. And I've only really talked about expressions up to now. I've talked about something that we can use inside find. We can use in aggregation, but we can use in find, in project, in update. Hey, update this record and make sure this array is sorted. Let's talk about aggregation. So something that we've not been able to do before and people have always wanted is, I want this to group this data together, but I want the top n elements in that group. So what does that mean? So for example, here, I'm going to aggregate my students. And what I want to do is I want to output the sort by the average score, and output the first name, the last name, and the average score. So what I'm really saying is for each subject, I want you to show me the top 2 highest scorers. Now, it was always easy to find the highest scorer. No, it was always easy to find the highest score per subject. It was a little bit trickier and uglier when you found the highest score to also find who had that highest score. I.e., you could pick the highest value of a field, but finding the other fields in that record required a bit of a strange hack. Now we have that solved because we're able to do top n. Find me the top 2 students and give me their first name, their last name, and that average score, and do that for every subject. Another thing that's traditionally been tricky to do in MongoDB is rounding dates. Now, you could do rounding dates in the simple sense of, well, I work out how many seconds it is, and then I do that kind of, mod 86,400, and that's going to tell me what day it is. But it's always going to return that day essentially as a decimal. Dates are sophisticated things with all kinds of confusing ways to work with them. So we've added date diff and date trunc, which are functions which work with dates in a much more intelligent way, as in they round off to the actual day. They tell us how many times we've passed midnight or how many times we've passed an hour. Basically, we convert date times, which are a computer's concept of time, which is seconds since 1970, into what we would think of as human times, actual days. So here, I can say, I'm on the start date and the end date, and I'd like to know how many days that is. Now, in these 2 examples, the actual number of hours between those 2 date times is the same, but one of them starts before midnight and finishes after it. So that's a day. One of them starts and ends on the same day, that's no days. Or you could say you could say it's 1 day and 2 days, depending on how you like to think about it as a human. But effectively, by using this, we're able to see how many times we pass midnight. We're able to take things like not leap days, like the magical extra seconds after midnight that happen now and then into account. We can take time zones into account. We can correctly compute integer arithmetic to say, how many days were you actually in that parking garage? Equally, we can use date trunc, which allows us to round things off to how many weeks is this, or how many days, or how many hours is this. So I can take a start time and an end time and work out how many integer hours it is. And by doing that, or by rounding off to the nearest day, or in this case, the nearest 15 minutes, I'm able to say basically group stuff together into 15-minute groups. If you haven't hit this problem, this is an interesting one, is if you've never had to do this, you don't realize exactly how hard it was beforehand. But we have added, in MongoDB 6, this really nice kind of proper date arithmetic. Oh, I see a nod. I like it. Somebody's nodding. They're like, I've done dates. Dates are bad. Pardon? Yeah, this man has had horrible dates. I'm really sorry for him. To be fair, I've had a few as well. Okay, I'm going to tell you about union with. So union with, traditionally MongoDB, you can do things to one collection. You can basically run an aggregation on a collection. But what if you want to run the same aggregation over multiple collections and just merge those results together? So we've introduced union with, very similar to SQL's union with. It basically says, run this aggregation on this, on this, on this, on this, and then glue the results together for me. So just a really useful thing to allow us to be able to even do a query across multiple collections. If you think about aggregation and just using match, you can say match on this collection, union with match on this collection, union with match on this collection. I queried 3 collections, I got 1 cursor back. I like that. You could use it with Atlas Search and say, hey, search this collection, search this collection, search this collection, and give me 1 back. Or you can use it to pull together different collections, and then interestingly, by using group, you can effectively do a different kind of join. Fetch the data from here, fetch the data from here, and then group it by the field I want to join on. So, here's how I would do multiple collections with union with. Basically, I'm going to say, I want to find this customer ID, and I'm going to set this field flag archive to set is archive true. And then what I'm going to do is I'm going to look in my archive, say looking in my archive database is a union with, collection is archive orders, and the query and archive is true. And the reason I'm doing that set is so I know when I query against my live data and my gigantic archive collection that I've created, it's going to return me the same query, it's going to run the same query on both, it's going to return the same results, but it's actually going to set an extra field in all the ones that came back from the archive just to let me know that's where they came back. So same query, customer ID is 123183 against my live data, some archive data I have, fetch it, but also augment the archive data and flag and say this came from the archive collection. As I say, reading the code isn't quite as good. If I can get across verbally what we're doing, that's better. Merge. Hands up if you haven't heard of merge. Oh, only one person hasn't heard of merge. Okay, cool. I'm going to talk to you because it's really important you know about merge. These folks have all heard about merge. That's cool. So merge, you can run any kind of aggregation. You can run a find or a sort or whatever on your database on a collection. But then you can take the results from that and you can basically automatically turn those still on the server into updates to something else. So you could say, hey, you know, I want you to search my bank balances collection, and I want you to find everybody who's got €1 million, and then take all of those names, and I want you to use all of those names or all of those IDs against my customers collection, and I want you to put a flag that says we're going to send them a letter telling them they're a star customer, or I want to make them a star customer. So you can basically take one query and still on the server side, convert that into a bunch of updates on another collection. Really, really powerful feature. People will say you can use it for updating materialized views, but that's just scratching the surface of how much you can do with merge. So merge, you know, this is a Steve Jobs style slide. It's got that word on it, and that's all you're getting, because I think this one is one that's just so much better done verbally. Probably still a complete waste of time because only that guy hadn't heard about it. But it defines up. It's not the somebody put in a slide to explain it. How dare they? Okay, so define updates by running a pipeline. Basically, run a pipeline that creates updates that apply to other records. Window functions. Window functions allow you to take one record and look at the records before or after it in order to make decisions about it. Now, what I mean by before or after it, I basically mean I can sort my records. I can tell them to sort by a particular value, and then I can compare each record to, say, the 3 that come before it or the 3 that come after it. Hey, if this is more than 10 times the average of the previous 3 documents, something has changed in a big way. You know, I'm looking at my share price, and basically every time I get a share price, every share price, let's look at the previous 3 instances of that share price, and if this has changed by more than 10%, I need you to return that because that share is suddenly changing. We can apply a whole bunch of mathematical functions. It's effectively signal processing that you can do in database. Look at each record in the context of those around it. We can fill gaps in data. You want your data to have 1 record per hour, but some of them are missing. There are functions you can run that will create those extra records for you. Go through my data. There should be 1 record per hour. If there aren't, please make blank ones. You know, how many items were in the warehouse each day? Well, actually, we're missing May 29th for product 1 there. There's a 4th blue spot missing. We can run a function which will create it, but it will set it to 0. We can also say, okay, go through and fill in these missing records, but estimate what the value should be for that missing record. So in this case, it can go through and it can actually say, right, you should have a data point here. You do not have that data point. I'm going to add it to your database, and I'm going to calculate its value based on either the one before it. I just make it the same as the last value we had for this, or the one before and after it, and say, right, it's on a straight line between what it was and what it is. You don't know what the price of a share was or the speed of a machine at a particular point in time. Well, let's just say it's the average of what it was before and after. So you can densify the data. And at that, I'm going to say thank you. Absolutely on time. Thank you very much. as I said, those slides are full of examples. Those are great examples, well worth reading. If you want a copy of them, you need to fill out this form. And also, if you give me any score under 3, you're not getting them.
It's a scale of 1 to 10, right?
Is it? I'm assuming it's 1 to 5.
Why are you not asking for 7 or 8, you know?
Okay, if it's 1 to 10, I want 7s.
I'm not sure what the scale is. Thank you very much, John. Amazing presentation. We do have a bit of time for questions. Do we have any?
Do we? Questions?
We always have questions.
They don't have to be about this. I mean, you know, I'll...
Anything.
Yeah.
You can ask him anything. Let me bring you the mic so everyone hears the question.
Can you do the union command with across different databases?
Can you do union with across different databases? Asya, are you still here? Can you do union with across different databases? She said you should try it. Okay, so that's a MongoDB answer for, I'm really not sure. There's quite a few things you can now do across different databases that you couldn't before, but I don't know if you can do union with across databases. But if you can, anybody paying attention this morning knows that we could create a virtual database in Data Federation and bring those collections into that database, and then you absolutely can.
Any other questions? And remember, this is John Page, so you can ask anything. Doesn't have to be related.
Although I am on a panel called Ask Me Anything later on, so you can also ask them there.
Also. Yeah. And if not, we do have the coffee break after this. So we will start again at 15 past with the next session for Schwarz IT, but we can still take questions. Okay, then, thank you very much.